Hey guys, last video for this scientific study of life work lesson. So I just want to focus on the scientific method. I won't go through the scientific method as you have slides going through that. It's really clear. Just want to emphasize, yes, it starts with observation. You always observe something, and then you ask yourself a question, and that question is usually informed by prior knowledge that you just look at online, usually peer-reviewed. It's a way better form of knowledge than other sources that cannot verify, right? So textbooks are also a good source of knowledge. And from that, you formulate an hypothesis, which is not exactly an educated guess, but we teach you that in an if-then format. I'm not really happy about that format. It's not perfect, but we're gonna roll with it this semester because your lab kit uses that. So the hypothesis will be really like if I observe that, then the prediction I see this. So the hypothesis is really the if part, right? So if I don't know, butter consumption influence Nobel Prizes in countries. That's a really silly thing, right? Wait for it, it's coming. It's not that silly. We'll talk about it in a minute. So if X influences Y, then I predict that Y will go higher as X goes higher. That's a prediction. So if hypothesis, then prediction, then you collect data to show that. You consult prior knowledge as well to see if your data fit, build upon, or contradict previous theories, previous information we knew. You draw your conclusion, and most of the time you go back to the circle with more observation because your conclusion leads to more observation. You want to build upon that, and once you're satisfied after several iterations, you pull all that together in a nice bundle in a peer-reviewed article, and you publish it. Why is it important to do it this way and not just put it out there? Because as we've just seen really recently in the COVID-19 crisis, some people have skipped that space, which is tolerable for scientists. They have those preprint capacities. So preprint is not peer-reviewed. It's like what Dr. Raoult from France, which is deplorable in my opinion, what he did, put out there that, and I'm French, put out there that information about hydroxychloroquine, and it turns out it wasn't peer reviewed because it's a preprint server. So you skip that step, you go to publish. Other scientists haven't weighed in saying is it good or bad, and then people use that. Well, it turns out he put out some data that was that was contrary to his conclusions, which turns out to make his study look like 100% of people recovered when actually people who died were put out of the study. Just really bad. There were really low amount of people in the study. We had the same issues years ago with GMOs, with the rats. Another study from a French person. Definitely French people are maybe not to be listened to in science. You can listen to me as a teacher, but you get the point. And there is also the same thing lately with the vaccines. So we can talk about that at the end of the video here. So I really want to emphasize that the peer review process is when other scientists look at your work and say, yeah, that looks okay. Or, oh, wait a second, your GMO study that you did with those rats, Seralini, that's the guy who did that, turns out all your rats are coming from a breed of rat that develops cancer, either way, regardless of eating those GMOs or not. So you showing that feeding GMOs to those rats leads to cancer is actually, you don't know because those rats will have developed cancers, and they do regardless. Raoul saying all those people surviving surviving COVID thanks to hydrochloroquine. Well, you don't know if it was hydroxychloroquine that worked because all the people who died from taking a treatment, you just took them off your study. So of course, if you keep only the ones that are healed, you conclude that 100% of the people taking the drugs are healed, but it's not the case. And we know now that hydroxychloroquine is not proven to work, and people are working on showing that it is or not. But we don't want to put the cart before the horse. We go for the scientific method, and then the peer review part is essential. So with that being said, I alluded to the butter and Nobel Prizes. What do I mean by that? Well, that's the main difference between the observational science, which is you go out there and you look at things and you just conclude on that, and the control study. Here you see scientists, they didn't make the coffee cups, so they don't know what's in the coffee cup, which type of coffee. They are just here to rank the coffee cups, right, based on their taste. And the fact that they don't know is really important because they won't bias. It's called double blind. They haven't put the coffee cups together and they don't know what's in there. So the double-blind process is when the scientist that put together the experiment, set up the coffee, is not the one ranking the coffee. And the double in it comes from the person that ranks the coffee is not the one who set it up. So it seems pretty obvious here, but it's the reason why you don't tell patients when they receive a placebo or not, because you don't want them to. We know the placebo effect. If you tell me that you're giving me a drug that's going to heal me, help me, and I don't know if it's a placebo or not, it still might help me even if it's a placebo. That's why we have a group in which we only give sugar pills compared to groups when we give the actual pill we want to see the effect of, because we want to remove the effect that's just due to taking a pill. Literally, humans like just being cared for. And so you give me a pill, it can be sugar, like homeopathy, it's all only sugar. You can just help me, and my body is going to cure and heal, not due to the effect of the drug, just due to the effect of taking the treatment. Same thing when you just do experiments on animals or on patients, when you prick them with a needle, inject them. You see the example of that baby experiment here. We have a control placebo when we prick the baby with a serum, which is saline solution, rather than with the vaccine, because maybe just the pricking of the needle and the injection is the cause. Because when you prick someone with a needle and you inject them with some solution, the body reacts, and that reaction may be enough to vanquish the infection, the virus. Whereas the vaccine needs to show that regardless of that prick of the needle, it acts, and for that you just do the placebo, which is you just prick with the needle, and you see that in this case there's a real reduction. So going back now that we talked a little bit about control and all, what do I mean by observational study being maybe like the Burr and the Nobel Prize experiment? Well, let's look at what we call spurious correlation, shall we? So spurious correlation is that website that shows you now, or book apparently, that shows you something really cool is, cool. Like as you can see here, there's mention of different things that go together and maybe actually are not related at all. So spurious correlations, it's just to exemplify that correlation is not always causation. If you plot the hanging by suicide, which is really sad, and nobody, I wish we could help everybody going through that and help them to go over it. And it's hard, it's not easy to go over it. There's a lot of things, like we need to be really careful in how we deal with those things. But just that's the first one that pops on their website. But maybe let's look at something else, right? Let's look at film of Nicolas Cage. Please take care of yourself out there, guys. If you need help, reach out. Okay, with that, also don't feel bad about reaching out. I reach out myself for help all the time, and I did it, and I really needed it, and it helped, so it's great. Okay, now, wow, all those things are really bad, but Nicolas Cage is not responsible for swimming pool drownings, right? The number of people joining in swimming pool over time seems to be highly correlated with the number of movies that Nicolas Cage does. And it's just to show you can do that with everything. The example of a butter Nobel Prize is true. It can be done. Like, look at that. The per capita cheese consumption and the number of people being tangled in their bed sheets and died of it. It's not because you eat cheese that you die tangled in your bed sheets, right? And yet there's a high correlation. You see 94.71%. So correlation is not always causation. The number of divorce rate in Maine and the per capita consumption of margarine in Maine, 99%. Do you think people divorce because they eat margarine? Probably not. And that's really what I wanted to tell you about when I showed you that observational science. You can see two things that seems to be highly correlated that go together, but yet they do not explain each other. So that's why you need to do a control experiment in which the only thing that is changed is that factor. And then if that factor influences the result, that's the cause. You cannot do that in an observational study. You cannot go out and look and see, oh, I see that, so that must be that. No, that's called the spurious correlation. Okay, that's it for this week. You guys take care, and I'll see you next time.